Hi, this is Nandini, and I'm going to talk on the topic sound behavior in enclosed spaces. Absorption. Sound waves generally get absorbed by soft and porous materials. This can reduce reverberation and echo. Common materials which can be used to absorb sound waves can be carpets, curtains, acoustic films. Reflection. Sound waves bounces off when they hit a hard surface. This causes echo and reverberation. The angle of incidence equals to the angle of reflection. That is, the angle at which the sound strikes a surface is equal to the angle at which the sound bounces back. Material. Walls, ceilings, and floors can be a medium to reflect sound waves. Next is diffusion. Generally, sound waves scatters in multiple directions is called diffusion. This prevents harsh echoes or concentrated reflection. Diffusers creates a more natural and balanced sound. Refraction. This occurs when sound waves passes through a different medium. Sound blends due to various variations in air temperature or humidity. Impact sound clarity in large and open spaces. This acts as a fundamental of the sound acoustics. Generally, sound acoustics is the study of how sound waves interact with the different surfaces and materials. So the key concept we already discussed is absorption, reflection, and transmission. Absorption is when the sound is absorbed by a soft material. Uh, and the reflection is when the sound waves bounces off and creates echoes, and transmission is when sound passes through walls and barriers, it gets transmitted. So, how it is important in architectural design is ensures optimal acoustics in houses, offices, and public spaces. This can reduce noise pollution and enhance speech clarity. Next is sound absorption coefficient. Generally, it means the proportion of sound absorbed by a material. This can range to 0 to 1. 0 will be reflective and 1 will be a perfectly absorbing material. So, how can we find this absorption coefficient? Is there is a formula. So, the coefficient value is equal to EA, which is absorbed sound energy, and EI, which is incident sound energy. So if we divide both these values, we will get sound absorption coefficient. So there are these factors which can affect this sound absorption coefficient. So the first one is frequency. Lower frequencies are harder to absorb. Material types does matter. So porous material, if it is there, porous material can absorb more sound. Thickness matters. Thicker material absorbs more low frequency sounds. And surface texture. Rough textures absorb more sound. Sound transmission and control. Sound travels through walls, floors, and ceiling. Poor insulation results in noise leakages. Lower frequency sound travels more easily through barriers. Generally, sound travels more faster in solid. So when it is passes through walls, floors, and ceiling, it can reach the next person faster. So there are these control methods which is used during this use of acoustic insulation and soundproofing panels, adding mass loaded vinyl or fiberglass insulation, sealing gaps and cracks to prevent leakage. Thank you.